It is given to me that 1 plus ai is the root of this equation, which means that we can replace all the z here by 1 plus ai. So 1 plus ai to the power of 3 minus 5 of 1 plus ai to the power of 2 plus 16 of 1 plus ai plus k. This is equal to 0. As for what we have here, I'm going to do a binomial expansion. It will be 1 plus 3 of ai plus 3 of ai square plus ai to the power of 3. Then minus 5, expanding this, it is going to be 1 plus 2 of ai plus ai square. Plus this, it is 16 plus 16ai plus k is equal to 0. Let's evaluate this. What we will have is now 1 plus 3ai. Here we have a plus 3 times a square times I square, and I square is minus 1, so minus 3a square. And here it is a to the power of 3 and I to the power of 3. I to the power of 3 is negative I. So here it is minus a to the power of 3i. Minus 5, let's multiply into, we'll have a minus 5, this times this, minus 10ai, and this times this, a square, I square. I square is minus 1, so this will be plus 5a square. Then plus this, 16 plus 16ai plus k is equal to 0. What we need to do is to regroup this whole thing on the left hand side so that it consists of the real portion plus I, the imaginary portion, and we will match it to the real and imaginary portion on the right hand side. Then we will try to solve for a and k. Let's do that first for this. If I were to group the real together, the real consists of this and this. So 1 minus 3a square. And the imaginary portion, it is going to be those that has I, it is going to be this and this. So we will have here a 3a minus a to the power of 3. We'll do the same thing for this. The real portion is going to be this and this. So it is 5a squared minus 5. And the imaginary portion is just this, minus 10ai. Let's group these two, which is going to be 16 and k, they are the real portion, so 16 plus k, and the imaginary portion is going to be 16ai. So what we have now are 3 complex numbers. I'm going to add this to this to this to form the real portion, 1 minus 3a square, then plus 5a square minus 5, and the last one here is plus 16 plus k, the real portion, and the imaginary portion, 3a minus a to the power of 3 minus 10a and plus 16a, I is equal to 0. And this will be 12 plus 2a squared plus k, plus this is going to be 9a minus a to the power of 3, I is equal to 0, which I can also express it as 0 plus 0i. So if I were to match the imaginary to the imaginary, what we'll get is a 9a minus a to the power of 3 is equal to 0, which I can factorize out a. So I have a 9 minus a squared is equal to 0. So a is going to be equal to 0, or a square is going to be equal to 9. A square is going to be equal to 9 tells me that a is either minus 3 or a is going to be equal to 3. According to the question, a is a positive real number, which means that a is equal to 0. It is not going to be applicable. So is a is equal to minus 3. So a is equal to 3 is our answer, and I'm going to sub it back into this particular equation to solve for k. According to what we have here, this is going to match to 0. So the equation that I was talking about is 12 plus 2a squared plus k. This is supposed to be equal to 0. And a is equal to 3, so 12 plus 2 times of 3 squared plus k. This is equal to 0. This will help me to solve for k. The value of k is equal to negative 30.